Hey everyone, today we are continuing with 1.4. So 1.4 was all about polygons and perimeter in the coordinate plane. So yesterday we did naming polygons. You did a little bit of notes on that, but you also did a quick IXL section to make sure we know the names of shapes. So the next thing we're going to do is flip to our notes on 1.4. So this first page here that says perimeter and polygons, that was something that we did yesterday. You guys did an IXL section. It was 8th grade 01 after you finished your quiz. And so we're going to flip to the next page where it says, what is perimeter at the top? Okay, so what is perimeter? You've probably heard of it before, maybe in elementary or middle school or something like that. Perimeter is just the distance around the outside of a shape. So let's go ahead and write that down. Distance around the outside of a shape. All right. So if you ever heard of someone like patrolling the perimeter or something like that, they're just walking around the outside. Anyways, so in a coordinate plane is the context we're using for perimeter today, which is going to require us to remember the distance formula. So we're going to get to that in a moment. But let's start with just an example of what we're going to be asked to do. Most of the shapes that we're going to be asked to find the perimeter of will be either a triangle or a quadrilateral, like a rectangle or a square or something like that. But we're going to start with a triangle. So this triangle is going to have 3 points. Point A is going to be at 1, 4. Point B is going to be at 1, -3. And point C is going to be at 4, -3. So those are our 3 coordinates. Now we're going to make a coordinate plane to go with it. So I'm going to start with just a couple of lines like that. There's our X and Y axis. And I'm going to go out 5 units in each direction. 1, 2, 3, 4, 5. And you want to try to space them evenly the best you can. I'm not a computer and neither are you, so they probably won't be perfect. But we'll try our best. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. All right, step 1, done. And most of these will have a coordinate plane already on the paper for you. This first one just doesn't. All right, next step. Graph your coordinates. So our coordinates, A is at 1, 4. So over 1, up 1, 2, 3, 4. There's point A at 1, 4. Point B is at 1, -3. So over 1, down 1, 2, 3. And then lastly, point C is at 4, -3. So over 1, 2, 3, 4, down 1, 2, 3. All right. Once we've graphed our coordinates, the next step is to actually connect the dots and make the shape. So we're making a triangle. I'm going to connect those two. That's a nice vertical line there. We got a horizontal line right here. And then we have a slanted line right there that, oops, doesn't quite connect, but we do our best. Pretend it does. Okay. So now we need to find the perimeter. So we need to find the lengths of all 3 sides and then add them up. And there's 2 sides on here that are going to be easier to do than the other. So here's the trick. For horizontal or vertical sides, you can just count how long it is. So for example, on this vertical side here, I can just count the distance from here to here. 1, 2, 3, 4, 5, 6, 7. That side is 7 units long. So then I'm going to write it down here somewhere, maybe collect some information. Side length AB is 7. Cool. The horizontal side, I can also count. That's BC right here. We can go 1, 2, 3, and know that BC is 3 units long. Well, that's great. We've got our two of our sides. The third side, though, is going to require us to do this. Remember the distance formula. So, diagonal sides, or any kind of slanted side, use distance formula. All right, and so remembering the distance formula, it's D equals big square root x2 minus x1 quantity squared plus y2 minus y1 quantity squared. All right, so for this, we're going to need to find the distance between these 2 points, A and C. So I'm going to pull those 2 points aside here. We know point A is 1, 4. Point C is 4, -3. And that was weird. Oh, there it goes.
Lisa Nairn, please come to the main office. Lisa Nairn to the main office.
Well, hopefully she does. All right. We've got x1, y1, x2, y2. Now we're going to put them into our big square root with the formula. x2 minus x1 would be 4 minus 1. y2 minus y1 is going to be -3 minus 4. 4 minus 1 is our next thing that we want to do. 4 minus 1 is 3. -3 minus 4 is -7. If you're ever not sure, just use a calculator. 3 squared, 3 times 3 is 9. -7 squared, which is -7 times -7, is 49. Then we just add those together. 9 plus 49 is 58. And then you're going to want to do this next part in your calculator. Because knowing square root of 58 is the answer isn't really all that helpful when I'm trying to find the perimeter. I want an actual distance. So second, you hit the second button, and then that x squared button that has the square root above it, that's the one we're going to click next, and then type 58, enter, and we get about 7.615 big long decimal. If it's not your final answer, like this is not my perimeter, you want to round to at least 2 decimal places in the meantime. So it's about 7.62. Okay, so now we know this side length is 7.62. So AC is 7.62. Our last step is to add all of them together. So perimeter, 7 plus 3 plus 7.62. You can use a calculator if you want to add them, but we should get 17.62. At this point, you can go ahead and round to 1 decimal place. Sometimes if you have multiple sides that are all like diagonal and stuff like that, you'll end up with something different because you rounded a few more places out. But in this case, since there's just the one, we can just round this to 17.6 and call it good. Okay. So just to recap what we did real quick. We graphed the coordinates. We connected the points to make the shape. We counted to find the horizontal side and the vertical side. We used the distance formula to find the diagonal side. And then we added all the sides together. Okay. So I know that's a lot of steps. That's why there's not going to be a lot of problems on your homework tonight. But let's go ahead and turn the page. We're going to talk about at least one of the problems all together. And then you guys will have some time to work on the rest of them. So turning the page, we get to this page. We have a puzzle time. Why was the geometry book so sad? Although I think I erased some of the problems because I don't make you do all of them. So you may or may not be able to find out why the geometry book was sad. All right, and so the first four, I'm gonna let you do on your own. Based on the name of the shape, tell me the number of sides of the polygon. That's from something we did yesterday. So for today, we're gonna start with number 5. And for your homework assignment, you're going to be doing 6, 7, 8, and 9 as well. So 5 through 9 are going to be the other part of your homework. All right. And on this one, for number 5, you've got this right here that you can graph on. For 6, 7, 8, and 9, if you flip the page over, you'll see more graph paper that you can use for any of those. So each one can have its own graph. All right. So here we go. Go ahead and plot these 3 points on your graph. Pause the video real quick, plot the 3 points, and then when you start it back up, you can see if you plotted them correctly. Okay, hopefully you paused it. So for plotting these points, point A is 8, 0. So 1, 2, 3, 4, 5, 6, 7, 8. A goes right there. It's the coordinate 8, 0. Coordinate B is -3, 2. So over -3 this way, 1, 2, 3, up 2. And then C is 10, 2. So over 10 this way, up 2. Okay. Then you want to connect the dots. So let's just do our best here connecting these dots. This side is the one that is horizontal. The other 2 sides are slanted. So we're going to have 2 distance formulas to do here for this problem. For the horizontal side, you can just count 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. The other 2 sides, though, AB and AC, we're going to have to do the distance formula. So for AB, this one right here, we're going to use this coordinate, -3, 2, and this coordinate, 8, 0. So pause the video here real quick. Try the distance formula out with these 2 coordinates, see what you get, and then restart it to see if you did it right. All right. So x1, y1, x2, y2, big square root. We're going to do x2 minus x1 first, so 8 minus -3 squared. Y2 minus y1, 0 minus 2 squared. 8 minus -3, anytime you do minus, adding a positive. So 8 plus 3 is 11. 0 minus 2 is -2. 11 squared is 121. -2 squared is +4. Adding those together, we get 125. And taking the square root of 125, we get approximately, in our calculator, square root 125, 11.18. So 11.18. All right, so that's this side length, 11.18. All right, next side, AC. For this one, we're going to use the coordinates 8, 0 and 10, 2. All right, try the distance formula again. Pause the video real quick, see what you get. Then rejoin us, and we'll see if we got it right. All right, x1, y1, x2, y2, big square root, x2 minus x1, 10 minus 8, y2 minus y1, 2 minus 0, 10 minus 8 is 2, 2 minus 0 is also 2. All right, and then 2 squared is 4, so 4 plus 4 here, which is 8. And then if we type that into our calculator, we should get approximately, let's see, square root of 8 is about 2.83. All right. So now we know this side right here is about 2.83. The last thing we have to do to find the perimeter is add them all up. 13 plus 2.83 plus 11.18. If I add all of that together, we get 27.01. You can add that in your calculator. In fact, please do. All right, 27.01. At this point, we can probably call it 27 or 27.0, I think is what you have down here. If you can find your answer down below, you probably got it right. There it is. So our answer to number 5 is 27.0. All right. Your task is to do 6, 7, 8, and 9, and then also 1, 2, 3, 4. We will go over any questions you guys have on Monday, but please do attempt all 4 of those, at least graph the shapes, and do what you can with the distance formula. Have a great rest of your day, and see you later.